Welcome, everybody. Very proud to introduce Blair and Keywald, who are authors of Breaking Bad with 3D Enterprise Systems. I'm Steve Hoberman. I manage Technics Publications, and we are a publishing company specializing in books on data. And there's three reasons for these book release celebrations. One of them is an awareness, to make people aware that this book exists. A lot of the books we publish fill very important niches in our industry, and you'll see how this book fills a very important niche. The second reason for these celebrations is really, well, for celebrations, really to acknowledge that Blair and Keywald completed a very challenging milestone. It's very difficult. It's actually very difficult to write a book, 40,000 words, 50,000 words, 60,000 words, but even more difficult to go through the whole publishing process and go through the editing cycles and rethinking things again and again and again. And so we're here also to celebrate that accomplishment for Blair and Keywald. And the third reason is really, I love hearing from authors on if they could summarize why they wrote the book and the key messages for the book in 20 minutes, 25 minutes. I always find that very fascinating, and I hope you will too. So just to introduce our authors, Blair has been architecting and developing enterprise software for over 40 years. He recently had the opportunity to reverse engineer many different systems for an organization to help them find missed revenue. And he saved the organization millions of uncollected dollars, was able to recoup millions of uncollected dollars. And this inspired Blair to evaluate how systems get created and why we struggle with integration, leading to this book, Breaking Bad with 3D Enterprise Systems. And Keywald is a dedicated researcher and developer committed to advancing the information technology industry through education, training, and certifications. I've actually known Keywald for many, many, many years. I was trying to think how many, Keywald, at least maybe close to 15 years, actually. And Keywald has built many standalone and enterprise systems around the world. He is committed to advancing our industry by continuously looking for new ways to improve our approach to systems development, data management, machine learning, and AI. Hence, his input to the book as well. So without further ado, I'm going to turn it over to Blair. Keywald and Blair, congratulations again. And Blair, welcome. Blair and Keywald.
Well, thank you. Yeah, I have been, well, first of all, thank you everyone for taking the time to, taking time out of your schedules to come and celebrate the book launch with us. And this has been quite a long journey, and Keywald has kind of been there every step of the way with me on that. And remember way back in, I think it's like 2017, Keywald, and I was just saying, hey, there's just such a need for educating people in terms of how to create enterprise systems. I felt like a lot of that education existed within ERP vendors. They would teach their developers, but I felt that, you know, the industry needed to provide that at a technical college level. So in Keywald, we kind of got on this project together, and he's been truly instrumental in terms of, you know, supporting me. He just, you know, kind of gravitated towards the ideas, recognized the need that we're trying to fill. And he's just been there every step of the way. And it's been, like I said, very important to me. So Keywald, is there anything you wanted to say? Oh, I muted
myself. Yeah. So, yeah, I think, you know, recognizing that the ideas that Blair was posting on LinkedIn for quite a while prior to that, there was a lot of insight into why we had been developing silo systems for so long. And so the silo system development process really is something we're all of us that have been in the industry, we've been taught that way in the colleges and universities. They still teach it that way. Every single class teaches a single project, and it always seems to be, you know, the same old cycle of requirements to implementation to maintenance. And that cycle of single application development gets fed into the industry And Blair has identified the fact that we've been doing it wrong for so long. We really need not so much wrong, but we need to improve what we're doing and make the industry aware that we have been building silo systems, whether they were individual applications or whether they were applications in an integrated environment that was standalone. So the ERP environments today are still, in our view, standalone environments that won't talk to other environments readily. And so you have large companies that implement those systems, and they don't talk to their other best-of-breed applications. So we know that we have lots of best-of-breed silo applications that don't talk to each other very well. And I think Blair had hit upon a way, a method, a technique, a number of steps that would solve some of those issues. And it was time for us to restart that whole process. So I recognized that as soon as he introduced me to some of his ideas. And we've now come up with the book that hopefully people will use as a guide to change their educational programs in the universities and colleges, and to change the way that software and applications are developed, and to change the way that data is stored, managed, regulated, governed, owned, and distributed. So, and we need that, especially when we're doing AI and ML, machine learning, to have much more accurate data. So, really, I think Blair can posit all of the great ideas that he's had. And I've just been along for the journey and tried to help as much as I could to get this out there in our industry, to make our curriculum developers and our business professionals and our technology professionals aware of why we've been so stuck in our inability to integrate systems. So Blair, let me pass it back to you.
Sure, that sounds good. So the book goes into quite a bit of detail in terms of, it's like a problem needs analysis, right? And it really, what we really discover is that our methodologies for creating enterprise systems has really severe limitations that affect our ability to easily integrate them. And, when I say enterprise systems, to me, what that is those financial administrative systems that sit in the middle of an organization to help them run their business. And so literally every organization has a financial administrative system. And the way that we used to create, when in the early days, like 60 years ago, and, I've been around for, I guess, 40 of that, but, it was perfectly fine. We could, we design a system, we implement it, and users are very happy to just get a system that meets their needs. And that was good. But as time has changed or gone on, we've seen this increased demand to integrate systems so that we're not rekeying and keying data from one system to the next. And we're seeing demands to take many different databases from many different systems and aggregate it for AI and management reporting. And so our world is changing. And so this is really stepping back and taking a look at how we do that. And as Steve mentioned, I had an experience many years ago, and that experience was related to, I went into an oil and gas company with a couple other guys, and we were paid nothing if we didn't find it, but if we were paid a percentage of the missed revenues, if we found missed revenues. And so my job was to reverse engineer these systems. And so I got all the data dictionaries and all the data from like at least 10 different systems, 27,000 attributes, all these thousands of tables. And I had to try to put, like a common, get some commonality or like a common naming convention over top of this stuff and try to connect it. And in the end, we actually found $7.5 million that they missed in billing, and they actually recovered that revenue because of the work that we did. But everybody needs to do this. And if everybody did that, they would probably be on the same crusade that I am. But when you take a look at all these databases and you look inside them, you'll see developers name everything exactly whatever they want to do in terms of tables and columns. They can name them so the same attribute has different names in every system. You'll find something common like, oh geez, well status, that's common. Well, no, because every system has a different number of well statuses. Some have 4, some have 3, some have 2. So even attributes that seem similar or different. In oil and gas data, there's a lot of temporal or time-sensitive data, and you'll see that every system handles it differently. They have their best processes for doing that, but everyone is different. Primary keys, every system, the developers that say, well, I like GUIDs and I like incremented integers and I like composite keys, and they will choose whatever key, whatever method that they like. And then when you take a look at the master data, and a tremendous, like in my opinion, 60% of the data that we look at in a system is master data. That's the reference data. That's things like oil and gas wells in this scenario, contacts. It's all of that stuff. And the same data will have a different primary key literally in every system. And so when you start trying to map this data together, it's extremely complex and time consuming. And you really very quickly realize, why we struggle with integration. Even things like, well, in this particular scenario, 20 different systems, each system had well records. Okay, which one is the gold version? And it really would depend. It's not from one system, because if that system that well was being drilled, well, that's the system. But if it's in production, well, it's there. So really trying to integrate these systems is extremely difficult. So it creates a ton of issues for our clients. When we create these systems and implement them, I think that our clients have just come to realize that, we just have to, rekey data from one system to the next. That's just normal processes. And then it's just normal that we use spreadsheets to aggregate data between systems and to, reconcile data between systems. And it really, in terms of management information, there's really limited management information when you start trying to span many systems. So if an organization has 100 different systems, they're not going to be able to easily aggregate data from all those systems. And we're having these pressures to leverage AI, but literally, if we can't aggregate the data, then we can't really effectively use AI. And AI, 80% of the 80% of the data or effort that goes into AI is just cleansing. The other thing is, in terms of an issue, if you take a look at hardware, every year, since I've been doing systems, we've seen our computing power go, up, and the cost of that computing power going down. Well, enterprise software is just the opposite. Like in the early days of us creating systems, systems were in the hundreds of thousands of dollars. And then we've seen systems go to $1 million, and then 10 million. And then, our clients have become kind of numb to this. It's like, oh, it's just a small change. It's just $1 million, right? And we see our numbers go to actually billions of dollars. So where other professions, not professions, but anyhow, other areas are seeing a decrease, we're seeing, in my opinion, an increase, and it's related to our challenges with integration. So one of the most popular solutions, and we've tried a lot of different things to try to deal with integration issues, creating little tools and, coming up with methodologies, but the most popular is to just implement a bigger system. So if you take a look at, okay, we have all these different independent little puzzle pieces, developers created all these different systems to meet different business requirements. Then we just implement a bigger system, like an ERP system. But the reality is ERP systems are developed with exactly the same methodology that we used 60 years ago. I mean, we give them a list of requirements, or they start with a list of requirements. Yes, it's a bigger list. they design a system to do it. They design a database using whatever naming conventions they want to use. They select whatever primary keys they want to use, and then they throw it into the mix, and then we try to integrate it. So it really, implementing a bigger system doesn't really solve the issue, and certainly systems can only get so big before they implode in their own complexity. So we really need, a new approach. But if you get to really take a look at the root cause of why we have these issues, it's because we have an integration last approach. So the integration last approach is, okay, we're going to define requirements, we're going to design the system, we're going to develop that system and with a database, we're going to produce a database that's as unique as a fingerprint. We're going to implement it, and then we're going to try to integrate it. And only, when we do that, we'll figure out, well, we can integrate it, but maybe on a couple tables, but certainly not on all the master data that exists in that system. So what is the goal? The book gets into, really doing, first of all, that root cause analysis, but then gets into formulating basically a goal and all the objectives and everything related to that. And really the goal, the very simplistic version of the goal, is to create enterprise systems that have an inherent capability to securely exchange data. That's it. It's really, so when we look at the diagram on the right, we see a lot of different, systems. All of those systems are interconnected like a network and securely exchanging data amongst them. So that's really the goal that we were striving to achieve. So in the book, we get into 5 key principles, and those 5 key principles I documented, first of all, on LinkedIn, and collected feedback on them. And it was really principles that came about as a result of the experiences that I had in creating systems. So, one of the principles is core models, and it's really core data structures to manage the core kinds of data that you would see in any kind of a business. So every business has contacts, they have finances, they have assets, they have HR structures, they might have data about contracts. It's really just a general business administrative system. And really those core structures, that the concept of using core structures is not unique. I mean, ERP vendors, when they go into to a new line of business, they don't redesign all their data structures. They take their they have finance structures that are already in place, and then they augment those structures to track new types of transactions, and they augment their contact structures to track new types of contacts. So these core structures, I would say that these structures are considerably more powerful because they have integrated into it this inherent capability to exchange data between systems. So the next key principle is primary keys. And this is basically the basic rule of these primary keys is they're assigned to every type of data that exists in the system. Transaction data, master data, and it's assigned once to that record, and no matter how many different systems it gets transferred to, that primary key never changes. So that allows us to move data between systems to, and then to update it after it changes. So there's a lot of information in the book in terms of how that primary key is designed and worked. The next one is record governance. So that really says, if we had 20 different systems and they're all dealing with data, then what system is holding the gold version of that data? So if we had 20 different in the oil and gas scenario, we have 20 different systems that are having an oil and gas record, which is the gold version? And it would be in this case, it would be very likely the entity that owned that oil and gas well. So there's a lot of rules around record governance, and really record governance is tied into the primary keys, believe it or not, but there's a connection that exists there. The next one is a data transfer principle, and it says we need to build into our systems an inherent capability capability to exchange data between systems. And so in here, this is like a conglomerate, and they've got like a main entity, and then they've got sub entities, and this could go down many levels, and they're all communicating within themselves, but then communicating through this thing I call the master data server to exchange data with other entities. And in fact, exchange transactional data, they can do it even outside of that. So that's the fourth principle. The fifth principle really gets into application frameworks, and it says, if we've created 1 million systems, in our existence, then very likely we've created almost 1 million different application frameworks. And the application frameworks really control the user interface. It's all those user interface features. It's all that utility software. So the book really talks about how we can create an application framework, very much like a web browser, so that we can create definitions for enterprise systems and then run it through this framework, which will present that user interface to the clients and basically be able to switch frameworks. So it gets a lot into the details in terms of what that framework would look like. So that's just a quick overview of the 5 principles. So what are we striving for? We're striving to enter data once and only once and share it with all the systems that need it. We want to be able to aggregate data from many different systems into a data warehouse. We want to support supply chains, so data can move from a supplier to a customer to his partners. We want conglomerates to be able to implement systems, like say government is like an example of a very complex conglomerate, to be able to implement systems for each of their departments and then have all those systems exchange data. Another big thing is we want to educate a workforce, and this is really where Keywall comes in, on how to create systems that have this inherent capability to exchange data. And lastly, we want to be able to empower organizations to take back control of their enterprise systems so that they can educate their workforce in terms of how to support these systems. So what have we done so far? We have published the design principles. I did that back in 2017, collected feedback. We've met and collaborated with thought leaders like Bill Inman. I developed the framework software and the methodology to accomplish it. And that was absolutely critically important because the book is not a book about vaporware. This is the software was developed. It shows how the data, it exchanges data. And there was a tremendous amount I learned by actually taking the principles and turning it into an application framework. Then it was documented in a book, and then, which is, I guess, why we're here. And then we set up a proof of concept environment to test it. And so I'm going to give you just a quick example, because I think a picture is worth 1,000 words in terms of, what this proof of concept environment is. So this is this environment, and imagine we've got, this is actually, I physically set up all of these systems. And so it's got like an executive office system, which would be the main executive office for that government. And they would have their own, it would be a full financial system, for them to manage their business, but it would also let them manage their contacts, their activities, their HR structures, and all of the things that, they need for the executive office. It has like a citizen registry that is, again, another fully operational system to manage their finances and budgets and HR structures, assets, and everything, plus detailed features for managing citizens and relationships and addresses. There's a vehicle registry. There's like an energy department that would be able to exchange data with oil and gas companies. There's a corporate registry, a public works department, a land registry. And then just to round out the scenario, it communicates with outside entities like a couple different municipalities. There's a bank system involved because banks often have encumbrances on mortgages. So, it's showing how we can exchange data with those. There's a consulting company that is involved, and it's sending data to the public works department. So to give you an example, let's say we went and we had an update to a citizen, and that could be they got married, they had a kid, they changed their name, changed their address. So that citizen registry is aware of every other entity that has an interest in that citizen. So as soon as a change occurs, that goes to this local data server, which immediately distributes it to all the systems that have an interest in it. It also sends it to the master data server, which is kind of like an email server, and distributes it out to to interested parties outside of that entity. So that's just one example. There's lots and lots. I could bore you with many examples of all the different ways that this system is exchanging data. The other one that is kind of interesting is the finance one, because with finances, each one of these systems manages its own financial system with budgets, and it's like a fully self-contained system. But if you can imagine, if there's a financial transaction that occurs in one of these sub-entities, then that's really a transaction that occurs for the main entity. So anytime that there's finance changes to finances, changes to budgets, that data automatically goes to the executive office. So it's automatically showing how that finance, or so that it's affecting the bigger entity as well. But because of primary keys and all that stuff, all the data maintains its original identifier, so that we can go back and update that data if it changes. And the other really big difference between this financial system and legacy ones is all the journal entries can be connected to any object. It could be connected to like a land parcel in the land registry system, or a vehicle in the vehicle registry system, or an oil and gas well. So it's really can be connected to all of those things. And then we can literally produce finances based on any of those data objects. We could say, okay, give me all oil and gas wells of this type. I want to see the revenues and expenses related to that. So that's a little bit about the, how that works.
So Blair, just to interrupt for a second. So you have, I know you've told me this before, but just for our viewers, this is an operational system that you have built in an SQL environment. In the whole framework is built, and it's ready to demonstrate to anybody that has interest, either to get involved in using the processes that we have illustrated in the book, or to even look at implementing within their own companies.
Yeah, that's right. So it was really developed as a proof of concept, but also as a training tool to educate people in terms of all of the features that exist within this environment. And so that's critical, and it had to be kind of working examples, and the working examples can get quite complicated. But that's the reality of what our business is. We have these complex transactions that interact with a lot of different systems. So it's really an educational tool to show how that would work. One of the really important features of this system is it has this ability to take data from a lot of different systems and automatically aggregate it in a data warehouse. So we could literally, and it's demonstrated here, you could literally have many different data warehouses, but you can go and say, take data from all of these different systems and then aggregate it into the data warehouse. And the most important thing is one of the most important things, it can also just update things when it changes. So that's literally, you have the ability to get every last table, every last column from every system, aggregate all of the data, and if somebody makes a change to their structures or to their data, that data warehouse will get updated. And that data warehouse could exist in a SQL database, it could exist in something like Hadoop or something like that. But so then there's a super powerful inquiry engine that's like a Google search for data, for master data, that I won't get into here. But all of those things are possible because of we're following key principles: primary keys, core models, record governance, data transfer. All of those things are necessary in order to achieve these kinds of features. So one of the big questions is, can ERP vendors already do this? you know, because it's really like, why should I get vested in this? You know, it's a big, to get my mind around this thing, it's kind of a big deal. Well, to me, it's almost like math, you know. It's when you get into it from an architectural perspective and you look at it, if you went to the ERP vendor and say, hey, what kind of primary keys are you using? And they said, well, I don't know. Well, that would be the first clue that there's a problem. But the next question would, if they said, well, we're using composite and incremented integers. Well, I can tell you 100% that they would not be able to transfer data between systems and do all the things that this does using composite keys. And it'd be like saying, TCP IP addresses, let's let everybody name their device, and we'll have a really strict naming convention so that they name it properly. And then we're going to use that as our keys for, you know, communicating between devices. So unless they are creating a primary key that allows them to assign a key to all master and transactional data and then move it to any other system without changing it, they're not going to be able to do this. If they don't have a concept of record governance where they've got, you know, the same record occurring in many different systems and not knowing which one is the go-to version. If they don't have a concept for record grouping, like, you know, when we share master data, it'd be nice to believe that it's just a single record. Oh, it's a GL account code or it's a cost center. No, it is so much more robust than that. It's like, we need to share, like a simple example is, we need to share a contact and their address. Right. And so if that subsidiary data changes, then everybody needs to get updated on what that is. In my examples, I literally have record groups that go down 7 layers deep in terms of starting at a parent record, going to child, grandchild, great-grandchild records. And if any of those records change, then it's automatically broadcasting it to all the other systems. Subscribers, you know, we need to be able to organize them in groups, and they need a really robust change history mechanism so that whenever master data changes, it automatically gets broadcast to all the systems. And that's really dependent on things like primary keys. So that's really, I think, like I said, it's like math. If they're not doing these things, they can't just magically pull a rabbit out of the hat and do it just because they say they can. There's some principles that they would have to follow. So 3 dimensions, the book is about 3D enterprise systems. So what's the 3 dimensions? Well, the first dimension is the data dimension. And we can do that in systems now. We can take data and we can analyze it and, you know, pull out reports and do data warehouses. So that's the first dimension. The second dimension is the system dimension, because we have all these different systems. And so we can go and say, oh, for this data, I want to see all the systems where that data originated. And you could say, I'm only interested in, you know, this data, but from this system. So you have, you know, the system is really the second dimension. The third dimension is the time dimension. And it's really, there's a tremendous amount of temporal data that exists in our system, like time sensitive data. And this thing has inherent capabilities. So we could say, I want to see all this data, but I want to see how it changed from this year to this year to this year. And it can do that. So that's really the 3 dimensions. Why we hope you'll read the book? Well, we really think that it's time for a change. And you know, hopefully this is the first step in that change, and will, you know, make people really take a look at how we create systems. And if we truly achieve that objective, they will really look at it and say, this is ridiculous. How can we create systems in silos and then try to integrate them? It's just never going to work, and we need to get to a new level. And so we hope that you'll take a look at this, that it will stretch your mind to this new dimension, and that we can get to that next level. And I really appreciate all your time for sitting with me today. Thank you very much.
Great. Blair, I just want to add one more thing, and that is, you know, we're really fostering generally accepted data management principles, and we're really fostering generally accepted application development principles. 2 ways that we can mature our industry to the next level, so that we're not just doing craft work, but we're doing repetitive, repeatable, rapid application development in a truly new manner. And we hope this book is the basis of all of those new opportunities for our industry.